In this video, we're going to be going over how to write the chemical formula of an ionic compound that contains transition metals. Now, transition metals are the elements that are located in the center of the periodic table, and notice that we don't know the charge of them. It's not really listed, and there is no way to remember them. So, what transition metals are these metals that can have these ions that change charge. It's actually pretty easy to tell from the name. If you notice right here, iron with Roman numeral 2, the iron in the iron 2 chloride is a positive 2 charge. And if you look at the next one, iron with a Roman numeral 3, iron 3 chloride, that iron in the iron 3 chloride has a positive 3 charge. So in the name, it's actually telling us what the charge of that ion is. So it's very simple. I'll have you know that on our resource sheet, however, iron 2 and iron 3 are listed, so that's another way you can find out the charge. Okay, we're lastly going to have to remember that the ions, they do have charge, but ionic compounds, they are neutral. So when the ions come together, they neutralize each other, so they don't have a charge anymore. All right, so let's take a look at our first practice problem right here. We have copper 1 fluoride. Now immediately we can tell that the copper is going to have a positive 1 charge. Okay, it's right there. But what is the charge of fluoride? We're going to need to find that out by looking at the periodic table. Fluoride is right here in column 7A as a negative 1 charge. So remember that. Okay. I do want to show you though that copper 1, we said it has a positive 1 charge because it's in the name. It's right here on the periodic, or right here on the resource sheet. So it's copper positive 1. Okay, so copper has a positive 1 charge, like we said. Fluoride has a negative 1 charge, like we said. And if you take a look at it, copper 1 and fluoride negative 1, the charges, they already cancel out. So it's already telling us that, okay, in our compound, we're going to need 1 copper ion and 1 fluoride ion. So we can write the chemical formula, which is just CuF, okay, 1 of each. So this one's pretty simple. Let's take a look at a next example. In this example, we have iron 2 oxide. So just from the name, iron 2, we should know that iron has a positive 2 charge here. Okay, real simple. Iron has a positive 2 charge. But what's the charge of our oxide ion? So let's take a look at the periodic table. Oxide is right here. So it has a negative 2 charge. Remember that. Oxide has a negative 2 charge. I still want to show you from the resource sheet. Iron 2, if you found it, it's right here. Iron 2. Iron has a positive 2 charge, like we said. Okay, so iron 2, positive 2. Oxide, if you remember, it's negative 2. Do these charges cancel out? Positive 2 and negative 2. Yeah, they do. So that means when we write our chemical formula, you're supposed to have 1 iron ion, 1 oxide ion. So it's just going to be Fe. Oh, this one's a little bit simple too. Let's take a look at the third example. In this third example, we have mercury 2 rather, and immediately we can know that, okay, mercury has a positive 2 charge. All right, easy. What about chloride? So let's take a look at the periodic table. Chloride is right here, so it has a negative 1 charge. So chloride has a negative 1 charge. Remember that. I do want to show you mercury 2 is listed on this common ion table. It's right here. Okay, mercury 2. So it does indeed have a positive 2 charge. Okay, so mercury 2 is Hg plus 2. Chloride, if you remembered it, is Cl negative 1. Do these charges cancel out? They don't. We're going to need more negative in this case, so let's do that. Now there's a total of negative 2. There's also a total of positive 2. So this makes sure that it cancels out. So when we write our chemical formula, we know that, okay, there's supposed to be 1 mercury ion. However, there's supposed to be 2 chloride ions. Okay? So when we write the chemical formula, HgCl2. There's 2 chlorides here. Let's take a look at another example. We have iron 3 sulfide now. Iron 3. Immediately, you should know, since there's a Roman numeral 3, that the iron has a positive 3 charge. What about the sulfide here, though? So let's take a look at the periodic table. Sulfide is this S right here. S should have a positive, or sorry, not a positive. It should have a negative 2 charge. S should be negative 2. Remember that. Okay. I do want to show you on our resource sheet. Iron 3 is listed. It's right here. Okay. Iron 3 has a positive 3 charge, like we said. Okay, so iron 3, Fe positive 3. Sulfide, if you remember it, is S negative 2. Do these cancel out? Positive 3, negative 2. They do not. We need more negative in this case. So let's add another one. Now we have a total of negative 4. We have a total of positive 3. They still do not cancel out. We need more positive in this case. So now we have a total of positive 6. We have a total of negative 4. They still don't cancel out. We need more negative this time, so we add another sulfide ion. Now we have a total of negative 6 and a total of positive 6. They cancel. Okay, so when we write our chemical formula, there's supposed to be 2 iron ions, and there's supposed to be a total of 3 sulfide ions. Okay, so let's write our chemical formula, Fe2S3. All right, let's look at one last example. In this last example, we have copper 2 phosphide. Copper 2, immediately from the Roman numeral, you can tell that copper has a positive 2 charge. All right. What about phosphide, though? What charge does phosphide have? Let's look at the periodic table. Phosphide is right here. Phosphide has a negative 3 charge. Remember that. Phosphide has a negative 3 charge. Let's confirm copper one more time. Copper is copper 2, rather. Copper 2 is right there. Yeah, copper 2 has a positive 2 charge. Okay, so copper 2 has a positive 2 charge. Phosphide, if you remember, has a negative 3 charge. Do these charges cancel out? Positive 2, negative 3. They don't. We need more positive now. So let's add another copper ion. Now we have a total of positive 4 and a total of negative 3. They still don't cancel out. We need more negative this time. Let's add another phosphide ion. So if we add another phosphide ion, we have a total of negative 6. We also still have positive 2. They still don't cancel. We need more positive now. So let's add another copper ion. So now there's a total of positive 6 and a total of negative 6. All right, they cancel. Perfect. Now we can write our chemical formula because we now know that there are 3 copper ions. There's also 2 phosphide ions. 3 copper ions, 2 phosphide ions. When we write our formula, we should have, again, 3 copper ions, 2 phosphide ions. So that was kind of it. So take a look at the example problems that you have, and take a look at the key when you are ready.